You have to tell about these physical processes. What about A? What is this conversion? A.
A is A. Where's A? There's no A.
Oh, sorry, one.
Yeah. One, it's gonna be from a solid to liquid.
So what is this?
Uh, solid melting.
This is melting. Yes. What about two?
Two is gas to liquid. So that's what's it called? I forget.
Mm. Gas to
Gas to
liquid.
liquid. Yeah, wait. Uh,
Mhm.
gas to liquid. What's it's like condensation. Yeah.
Yes. The particles are condensing.
Yes.
Okay. Third, three.
Uh, three. It's gonna be liquid to solid. So it's gonna freeze. Freezing.
Freezing. Okay. Freezing. What else
Yes.
we say about freezing? This is known as
Sublim.
solidification.
Yeah.
No, no, no.
Solidification.
Yeah, sublimation means you are directly converting a solid to a
Yeah.
gas.
To a gas. Yeah.
Yes.
Without
Yeah,
liquid. Yeah.
without the liquid. Okay, there is no intermediate conversion. Okay, what about four?
Four. It's gonna be liquid to gas. So
Hmm.
that's boiling.
Yes. And what we say about boiling? What else we can say? That is
Boiling and wait. Look.
evaporation.
Yeah.
Yeah,
Vaporization or evaporation.
evaporation. Yeah, or vaporization. Yeah.
Mm.
One difference between boiling and evaporation is the rate at which processes occur. State one other difference of the boiling and evaporation.
Boiling and
You
boiling is
understand?
with,
Did you understand the first point? This
yeah,
difference.
one difference. Yeah.
What is what they are saying? How their
Bo-
rate is
bo-
different.
because boiling occurs like at the surface, and
Hmm.
evaporation happens throughout the substance.
Yeah, throughout the that is the answer. I am asking, what do you understand by the first line? That the boiling and
One
evaporation
difference,
is the rate at which the process occur. What does it mean?
like uh, like one difference between boiling and evaporation is the rate which,
Hmm.
like when does the, like, at which time does the process occur. So boiling happens at a fixed temperature and evaporation happens at a different temperature.
Yes.
At Yeah.
And in this, actually, they are telling us about the rate, like which one occurs at faster rate and which ones occur, which one is a slow process. Okay, so there is a difference in
Yes.
the rate. Can you tell me which one is fast, boiling or evaporation?
I
Which can be
think
fast? Hmm.
boiling.
Yeah, because this is a surface phenomena, right? So it is
Yes.
fast. But the evaporation, it occurs throughout the liquid. That's why this is a slow process. Okay, so this is the difference they are telling us in the first line. This is first difference. Second difference, you have told me about this, that boiling is a surface phenomena while evaporation occurs throughout,
Mhm.
right? Okay. mm, you can undergo the following changes. Describe the separation arrangement motion of the particle of element x in the solid state. Okay, x is in the solid state. Now you have to tell the separation among the particles, arrangement of the particles, and the motion of the particles.
So like you have to say like what happened at like
Now
X.
read this.
Describe the separation, arrangement, and motion of particles of element X in the solid state.
Yeah, in the solid state you have to tell. Okay, this X,
So
it has three states. It can be solid, it can be liquid, or it can be gas. But you have to tell
yeah,
about the solid.
the solid.
Yeah,
Yeah. So the arrangement will be like in a lattice form.
yeah, there will be a lattice.
Yeah, and the motion will be
Solid.
like yeah, like
Hmm.
not random, like,
Vibrate at fixed position.
yeah, vibrate at fixed position. Yep.
What about separation? Separation of particles.
What do you mean by separation?
Separation of particles. Are they separated or are they close?
No, they're
Separate.
closely
Yeah.
packed.
So we will say they are very close
Hmm.
to each other.
Yeah.
Yeah. Now, if you have to mention in these lines as well, okay, you can just make one line for this, that the separation of the solids is, in this we say that simply you can say the solids are very close to each other. They have a proper lattice and they vibrate at fixed position. Okay. If they have mentioned
Hmm.
the lines, you have to mention it.
Hmm.
The question is about iodine and compounds of iodine using the kinetic particular model to describe the separation between the molecules and the type of motion of the molecules in solid iodine and iodine gas. This is the repeated question, but with a
Yeah.
different type. Yeah, we can skip this.
Yeah. Yeah.
The graph show how the volume of iodine gas changes with pressure. The temperature is kept constant. Yeah, now temperature is constant. See, I told you one thing will be always constant. If you have three parameters, there is volume. Now they are talking about volume and they are talking about pressure. So temperature is constant, right? You get
Uh,
this? Like, there
yeah.
are basically, we have three things: volume, pressure, and temperature. If at one time you are talking about volume and pressure, then at that time temperature will be constant. Okay.
Yes.
And at if any time if you are talking about temperature and volume, then pressure will be constant. Okay. This is
Yeah.
what I am saying. At one time you only discuss two parameters. So in this they have discussed volume of iodine with pressure. Now what this graph is telling us?
Yeah.
Hmm? What
So
we
like,
huh?
yeah.
How the volume
So
of iodine gas changes with pressure?
like when the volume increases, the pressure will increase as well.
No, is it direct relation?
Oh no, it's in indirect because
Yeah, you see
uh
how we check. You will check this point.
like,
Okay, this point.
yeah,
This is,
before the graph, the slope
yeah.
used to.
You will the slope. Yeah, how to use the slope point like this. This one is the pressure. The pressure is, let's say, 1 atm, but the volume is now what? You can say 100 centimeter cube. Okay.
Yeah, so like
After
as
some
the
time,
pressure will increase,
hmm,
the volume will decrease.
decrease. Okay, so this is how we check by slope,
Yes.
by calculating the slope.
Yeah.
Yeah. Okay. So this is inverse relation. Whenever we have a direct relation, the graph will be like this. Okay. This is a
Mhm.
direct relation. Okay. Sulfur dioxide melts at minus 73 and boils at, what is the physical state of sulfur dioxide at minus 20? Yes.
Um, like sulfur dioxide melts at 73 and boils at -10. So like at -20, it will be
Hmm.
at -20. It will be at a gaseous form.
Yeah. No.
Yes, because -10 it will boil. So
Hmm. So what we are doing?
no,
Are
no,
we
no.
increasing the
Sorry,
value?
sorry. No,
We are.
sorry, sorry. Yeah,
Hmm.
decrease. Yeah.
Yeah.
So it's gonna be in a liquids.
Yes. It will be a liquid. The more
Yeah, because
negative means
yeah, yeah,
it is above the melting point. Okay. It is above the melting
yeah,
point, and then that's
yeah.
why it is liquid. Okay. You get this, or should I explain this?
No, no, I got that.
Okay, okay.
I thought like there was no minus. So yeah.
Hmm. Yeah, that's why they give such questions, because sometimes students don't see the signs, and
Yeah.
they know everything, and these types of mistakes this happens. That's why practice needs we need to practice. Okay, you are practicing the other past papers as well, the
Yes.
physics and maths. Okay, how you practice those with teachers, or they
Yeah,
assigned you?
yeah, with teachers, but I think from next week I'm gonna use like only for maths, like this website
Why?
because like for maths I'll take most past papers, but most of the teacher has past papers. I'll do like the what's it called, like flashcards and quizzes for each
Yeah,
thing from like
yeah.
this Friday, I think.
And it is also good for, you should practice the MCQs from this.
Yes.
I don't know which past papers they are using, but this is the updated website. Sometimes the teachers have past
Mhm.
paper, but they are very old. Okay, so that's
Mhm.
why I don't recommend those past papers. So on this website they update. There is always a new version. So I prefer that, and I will ask you that about this. Okay, about the other subjects as well. That
Yeah.
which past papers they have, the teachers. Mm, okay. State some physical property of the matter can be explained using kinetic particular theory. The diagram shows the arrangement of particle in three different substances. These are the three different substances. Now, can you tell me which substances are these?
Um,
The first
like
one.
the
What
first
is it?
one is liquid
Yeah.
because
What?
it's like
Mm.
not closely packed but not
Mm.
so far apart.
Yes. The particles are
Yeah.
close but randomly arranged. Okay.
Yes.
What about
And
second?
the second one is a solid. It's like in a lattice shape,
Hmm.
very closely packed together. And the third one is gas. It's very far apart from each other.
Yes. Identify the state of matter represented by each diagram. Yeah, we have done this. Explain in terms of particles what happens when solid is heated until it become gas. Okay. Now you have to explain in terms of particles.
Yeah.
What happens?
So like when it's heated, they can like the intermolecular forces will break down because of the heat, and the particles will increase will increase the speed and will like collide with each
Hmm.
other very quick, and
Hmm.
that will break like the intermolecular forces of the solid, and
Yes.
when it reaches the like that when it breaks all of the intermolecular forces, it will become a gas
Yes, it will become a gas. Good.
because of the collision.
Hmm. This is the last question, then we can end. A student investigate how changing
Okay.
the temperature and pressure affect the volume of a gas. The student fills a balloon with helium gas and place it in a freezer. Predict what happened to the volume of the balloon as the temperature decreases. What will happen when the temperature will
Um,
decrease?
like if the temperature decreases,
Hmm. What happens to the volume?
it
You
will
know
stay
the
normal.
no, 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 no. Volume and temperature both are directly related to each other. Okay. So if temperature
Mhm.
is decreasing, what will happen? The volume will also decrease.
Yeah.
Okay, so we will say the volume of the balloon decreases because the balloon shrinks. In freezer, it will shrink. Okay,
Okay. Okay. Yeah.
and the balloon is removed from the freezer and taken to a mountain. Now they
Yeah.
are saying that you have taken it to the mountain. It means what you are doing?
So it will increase. The volume will
Yeah, the volume
increase.
will increase. It means the particles. There are more random motions. There will be expansion. Okay,
Yes.
and the volume will increase. Okay, uh, we can end here.